What happens when you accidentally misdefine your variables is you reallocate the value to someone else or to something else. Yasmin's true value was 12, and Zippy's true value was 8. But because you misnamed and mislabeled the variables, you can switch the values. Welcome back to my channel. Today, I'm going to do a video on what happens when you misassign or name a variable. I discussed this in my podcast, and I wanted to show you this in math because with math, we can see some deeper things opening up about value that we may not see when we just look at it without numbers. So I'm going to use just this example that I found on Khan Academy. It's a basic example, and this skill is solving systems of linear equations. And it's a word problem, but it's one of the easier ones because they have defined the variables for us already. And some of these problems, you have to take just the blanket situation and determine what variables you're going to use and what needs a variable assigned and how you're going to model that with math. So for this particular problem, we have Yasmin and Zippy entered an apple pie eating contest. Together, the two ate 20 slices of pie. That's a key information right there. Together, they ate 20 slices of pie. And Yasmin ate 4 more slices than Zippy did. Which of the following systems of equations represent the situation in terms of y? The number of slices of pie Yasmin ate, and Z, the number of slices of pie Zippy ate. Okay, so that's why this is going to be a little bit easier for us to set up because they're telling us that they want Y to be the number of slices Yasmin ate, and Z is going to be how many Zippy ate. So let's look at the information given in the problem. And it says together they ate 20 slices of pie. So that means if I take the number Yasmin ate, which we don't know yet, and add it to the number Zippy ate that we don't know yet, the total is going to be 20. So that is one equation. That's one piece of information that we can use. And I'm so used to using X and Y, but let me change this to Y and Z. Okay. And you'll know why I'm so used to using X and Y. If you know, you know. All right. So Y plus Z. All right. Now for the next part, Yasmin ate 4 more slices than Zippy did. Okay. So the number that Yasmin ate, which is represented by I, is equal to 4 more than Zippy. So Zippy, this many, we're going to call it Z plus 4 is equal to how many Yasmin ate. Okay. So these are the two equations that model the situation. Let's look for our answer and choose. And we have to be careful because the variables are all mixed up. So we're looking for y plus z equals 20 and z plus 4 equals y. And looks like B is the answer we're looking for. Okay. Now, what I want to do here is we can actually figure out how many slices Yasmin ate and how many slices Zippy ate. Does anybody know how to figure that out? Raise your hand. Feel free to put it in the chat or come on the mic. LOL. But we can figure out how many slices each one ate by using methods for solving systems. Now, there are 3 main methods that we teach in school: substitution, elimination, and graphing. And I'm going to basically be using substitution. And so when I use substitution, it means that I'm going to manipulate one of these equations so that I can substitute for a variable into the other equation. Okay. So let me show you what I mean. So let me separate. Let's take z plus 4 equals y. Now, I can manipulate this equation if I know the laws of equality. Okay. I can move things around. Now, what's easy about this one is I don't necessarily have to move anything around for this problem. It's telling me what y is equal to. Y is equal to z plus 4. So if I go to my other equation, okay, I can substitute the expression for y into that equation. So that's what I'm going to do. So instead of, well, let me just write it so we can see it. Y plus z equals 20. And instead of y on the line underneath that, I'm going to write the expression for y, which is z plus 4. So that gets to go in the place of y, and I'm still going to write the rest of my equation out. Okay. So I have the expression for y here plus z equals 20. I haven't changed the value of this equation. I'm only changing the way that it looks. Okay. So now if I look at this equation, let's just take a look at it. I have one variable and I can actually do some things. I can combine like terms. I have z plus 4 plus z. So that means I have 2z plus 4 equals 20. Now, again, using the rules of equality, I can manipulate or move things around. So this equation is like a scale. It says that the quantity on this side is equivalent or equal to the quantity on the other side. There are some things I don't know yet, and we call them variables. Okay. We represent them with letters, but they represent numbers that we just haven't figured out yet. Okay. But I can work backwards to isolate the variable or the unknown, which is z. So, what I'm going to do is I'm going to take 4 away from the left side of this equation. And I'm also going to take 4 away from the other side because, in that sense, I'm keeping my scales balanced because I'm trying to get this all by itself to see how much is left. So let's take 4 from both sides, right? 4 minus 4 is 0. So all I'm going to have left is 2z on the left side, and then 20 minus 4 is 16. Now I have 2 times z equals 16. And if I want to undo that, since I have a 2 multiplying to the z, I can divide a 2. And whatever I do to one side, I have to do to the other because that is a rule of equality. And so when I take 16 divided by 2, I get 8. So now I know that the quantity of z that we didn't know at first is a quantity of 8. Okay, so that means Zippy ate 8 slices of pizza. That's how many slices he ate. So now that I know how many slices Zippy ate, I can figure out how many slices Yasmin ate. So if I go back and look at my original equations, y plus z equals 20. Total, they ate 20. So if Zippy ate 8 of those 20, I can do this in my head, but 20 minus 8 leaves me with 12. That means Yasmin was hungry, and Yasmin ate 12 slices of pizza. Okay. Yasmin ate 12 slices of pizza. All right. So now with this equation, we see that unknown variables, that's what they are, unknown variables or unknown variables have values that we're trying to uncover. Right. We can use math to model or set up a situation to look at numerically. This happens all the time, even if we never set up actual equations. What our head is doing when it's thinking is setting up the way things relate to each other all the time. Equations are just a concrete example of how we're showing the way things relate. So we're showing the relationship between how much Yasmin ate and how much Zippy ate. We're showing a relationship between that by writing y plus z equals 20. So we can interpret that as they both together ate 20 slices of pizza. Another thing that we know is that Yasmin ate 4 more than Zippy. And so there's a way that we can represent that with math. In algebra, a lot of what we do is practice this skill, is determining relationships and quantifying them with numbers, assigning a quality or a quantity to these different aspects and determining how they fit together, how they relate together, and modeling it with math. This is one of the more simple examples because it's an equation. But a lot of times there are inequalities because life is not always this neat and clean. A lot of times things aren't as simple as this. And I'm going to show that in the next example. But I want to talk about the principle of renaming or misnaming and reassigning names that are incorrect. Okay. So we have this situation with Yasmin and Zippy, and here this is what happened, right? But what if you took this problem and we were not given the information of Yasmin's going to be Y and Zippy's going to be Z? What if you were just given the first part, the scenario, without the answer choices, which means you were given this information and you had to derive your own equations from this? Okay. Well, that didn't copy over so well. Okay. So, what if this was how it happened? All right. Sorry about that. So, what if this is all you were given and you had to take that information and come up with your own equations? And what if you decided to use like A and B and you said A is going to be how much Yasmin ate and B is going to be how much Zippy ate, right? And then when you started to put your equation together, instead of let's say that you know that A plus B equals 20, right? Okay, and then you decided to say the number that Zippy ate equals the number that Yasmin ate plus 4. And then you went forward to solve this. Okay, so now you would solve it. You would go through all of your steps. You would substitute. You would get A plus 4 equals 20. You would get 2A equals 4. I'm sorry, 2A plus 4 equals 20. You would solve for A, subtract 4 on both sides, divide by 2, you would get 8. And this would say that Yasmin ate 8 slices. And you went ahead and you solved for B, which was Zippy, and you would get B equals 12. And so then your answer would say that Zippy had 12 and Yasmin had 8, when that was not the case. That was not the case. What happens when you accidentally misdefine your variables is you reallocate the value to someone else or to something else. Yasmin's true value was 12, and Zippy's true value was 8. But because you misnamed and mislabeled the variables, you switch the values. And for someone who doesn't know, they would look at the math and say, well, the math is correct because the math is correct. The math is going to work out to be that one person ate 8 slices and the other ate 12. But in your aggregating of the problem, if you misname the variables, you will reallocate the values. So it's really subtle, but it's there. Another example, I got this problem straight out of a state algebra proficiency test. And let's look at this problem. Mr. Carnegie will buy pencils and pens for his students for the school year. He can spend no more than $30 on pencils and pens. Pencils cost 15 cents each, and pens cost 75 cents each. He needs to buy at least 3 times as many pencils as pens. Which of the following systems of inequalities can be used to determine the number of pencils that Mr. Carnegie can buy? So, when we look here, we've got a lot to do on our own. We have to be able to, first of all, we've got to we've got to pick variables. Which letters do we want to use? Which one is going to be pencils? Which one is going to be pens? Then we have to model the situation, describe the relationships with numbers in equations, or in this case, inequalities. And then lastly, we actually don't have to solve here. They just want us to pick the equations. So there may be like a part B to this question where you have to determine how many pencils and how many pens Mr. Carnegie needs to buy. So let's just work on modeling, and then it's another opportunity for you to observe all the ways you can mislabel your variable if you're not assigning the attributes correctly to the prescribed entity, basically. Okay. So he's going to be spending $30, right? No more than lets us know that we're going to be using an inequality because this is not equal to. He can spend any amount less than $30. He's not spending exactly $30. So we have two quantities that we have to represent. We have this quantity of the money that he can spend, and then the quantity of the pens and the pencils. And we are describing their relationship. So, first of all, if we know that he can spend no more, let's determine which inequality we're going to use. Now, this tripped up a lot of people, inequalities, because it's like, well, which one are we talking about? And these are all the inequality symbols. We read them left to right. Okay. So I want you to slow down, especially if you're dyslexic. You have to train your eye to look from left to right because in this language, that's how we read things. Well, in the English language, we read from left to right. I know in other languages, they read right to left. So looking from left to right at the first symbol, we see the small end first, then the wide end. Okay. We also see this line here, which just means or equal to. Because the little n becomes first, this is less than or equal to. Okay. So it includes all values less than 30 and 30 as well. The second symbol is greater than because the big side comes first if you look carefully from left to right. So this is greater than or equal to. That means all values greater than 30 all the way to infinity. That means it doesn't stop. Okay. Any value greater than 30 as well as 30 itself. Okay. Now, for these last two, they do not include or equal to. All right. So less than, and then this one will be greater than. Okay. So now, which symbol do we need to use? He's buying pencils and pens, and he can spend no more than $30. So can he spend everything less than or equal to 30 or everything greater than or equal to 30? Okay, you're right. That's it. He can spend everything less than or equal to $30. So that is what we put in. Now, here's the thing, depending on where you place what, you've got to be careful that you place the symbol the right way. Okay. So again, the symbol is showing the relationship between what's on the left and what's on the right. So what you're essentially saying here is is the cost of the pencils and pens is less than $30 or equal to $30. That's why it goes this way. If you were setting your inequality up and let's say that you had written $30 on this side, and then you were going to be writing and representing the pens and the pencils on the other side, your symbol would face the other direction because you've got the 30 on this side. So if you got the 30 on this side, then what you're still saying the same thing, right? You're saying that the cost of the pens and the pencils, looking from this way now, is less than or equal to $30. I think that's the easiest way to understand it. I put myself in the position on the other side and I look to the left. I know that might be a little bit weird, but that helps me understand the relationship that I need to show or describe. All right, we're still not done. We are describing the relationship between the cost of the pens and the pencils and the $30 that we have to spend. So this is what we have so far. Now, let's move to the next piece of information. Pencils cost 15 cents each. Pens cost 75 cents each. So now we've got to bring some variables into the mix. This time we are going to use X and Y. Let's say that X is going to represent the cost, no, the number of pencils, and Y is going to represent the number of pens. How do I represent the cost of a pencil? If it's 15 cents each, you've got to ask yourself, what operation in math shows me that? So yeah, in your head, you're like, well, yeah, you're going to be adding 15 cents every time for how many? But how do we show that for multiple pencils, multiple pens, multiplication? So what that looks like is 15 cents times X. So here, this makes it so we can insert how many number of pencils he decides to buy. So let's just do the math. If he bought one, we will be putting one in there. He'd spend 15 cents. If he bought two, he'd be spending 30 cents. Okay, and so on. So this is how you represent. If he bought three, he'd be spending 45 cents. So this is how you represent what's happening over time. So let's go ahead and put that in there. So we know he's going to be spending 15 cents per pencil. And then we're going to be adding that to how much he spends on pens. All right. And since we just explained that, we know it's going to be 75 cents times Y. That is one inequality for our system. This represents how much money he's going to spend, accounts for him not being able to spend more than $30. It accounts for the difference in the prices of the pens and the pencils. And we still, eventually we're going to figure out how many pens and how many pencils. Now, moving on to the last bit of information. This one is a little tricky. He needs to buy at least 3 times as many pencils as pens. So we've got to break this down and really look at it and think it through because it's tricky. He has to buy at least 3 times as many pencils as pens. So we know that we're comparing the number of pencils to the number of pens. This is what we're comparing. So that means you're going to have X something and Y something. Now, are we using an equation? Are we using an inequality? Well, let's think about this here. Which one needs to be more? Obviously, one needs to be more than the other. That's not equivalence. That's inequivalence. That means we're going to be using an inequality. So now let's think about it. Which one needs to be more than the other? He needs to buy at least 3 times as many pencils as pens. So that means we're buying more pencils. We're buying more pencils. So the number of pencils needs to be the number of pencils needs to be greater than or equal to the number of pens. But how do we show that? How many though? 3 times as many. So that means we're going to be putting 3 here. 3 times as many pens. So the number of pens times 3, right, needs to be equal to or less than the number of pencils. Okay. So this is real easy to get backwards where you put the 3 next to the X. But if you just take your time and think through it, you can get it. So now we have the other inequality. And this question just needs us to choose the answer, which I believe is B. I think sometimes when you're solving or setting up your inequality or equation to model the situation, you could accidentally get your X's and your Y's mixed up. I think in the first inequality, it's pretty straightforward. Yeah, it's going to be 15 cents per pencil and 75 cents per pen. But down here, it's tricky. There could be an honest mistake getting the X and the Y mixed up, especially because one inequality is correct and the other one is not. I think we would end up with incorrect answers. But if they were both set up in the incorrect way, we would still get the right numbers. They would just be swapped. Okay. So in algebra, in math class, these are some ways that you can make an honest mistake, right? Now, what I've been teaching about is this tactic of renaming, reassigning, and how that can reallocate value when this is done intentionally in life, where there's a scenario for one entity and a scenario for another entity, but I start calling the one entity something different. I basically switch their names. Then in everyone's minds, or in how that information is relayed, the values get switched. The number of pencils now becomes the number of pens that you need to buy, and the number of pens that you need to buy becomes the number of pencils that you need to buy. So I hope that this landed. I hope that you clock this. I'm thinking about doing another video where instead of me using examples from math class, I'm going to use I'm going to use scenarios that are more related to the topic of discussion, which would make them more abstract and not as concrete, but the principle still remains. When the variables are swapped, when the names are swapped, the values get reallocated because the math is going to math. The math are numbers and it's going to work out the way it's going to work out. But if you've misnamed anywhere along the way, the number of pens that you need could actually be the number of pencils that you're buying and vice versa. Or you could be blaming Zippy for eating 12 slices when he only ate 8. And Yasmin was the one that was eating 12 slices. So I hope this landed. Let me know your thoughts and I will talk to you soon. I'll see you on the next video.
This is Sacred Algebra.